Today we will discuss about the factors on which the resistance of a conductor depends. Let's see now. So we will discuss what is resistance if a conductor is taken like this and a potential difference is maintained or applied across that conductor. The charge of the cell will draw those electrons from these atoms of the metallic wire. So those atoms will be positively charged ion. So electron will collide. So electron will face difficulty in flow. So that is called resistance. So what is basically the resistance is? Resistance is the difficulty in the flow of the electrons. So if the length of the wire, if the length of the wire is increased, what we will get? The resistance will be increased. How? If the wire or the length of the wire is increased, electron will undergo more and more collisions. So collisions is called here as resistance. So resistance will be increased with the length because electron will face more collisions. So here I have written the explanation in the slide. As the length is increased, the number of fixed positive ions increases, thus the collision of the free electrons increases. This increases the resistance in the conductor. Thus the resistance is directly proportional to the length. Okay, we will now see how the resistance depends upon the cross section area of the wire. So if we take two wires, one of the wire having cross section area A1, another wire is the cross section area A2. So the A2 is greater than A1. So due to the larger cross section area, the gap between the positive ions will be increased. So electron will face lesser collisions. So the probability of getting uh, collide with the ions will be decreased. So how can we say if the area is increased, the electron will collide lesser, and this will decrease the resistance. So explanation is written in the slide because the space between the positive charges increases, therefore the electrons will undergo comparatively lesser collisions, so resistance decreases. Also resistance of the conductor depends on the nature of the material. Different materials have different resistance, like conductors have lower resistances when the temperature is taken very low. So nature of the material is also an important factor that could affect the resistance of the conductor. So we can conclude the resistance depends on length, cross section area. Resistance is directly proportional to the length and inversely proportional to the cross section area. How? If the cross section area is increased, resistance will get decreased, as we have seen in the previous slide. So conclusively we can write here as resistance is directly proportional to the L upon A. If this proportionality sign is replaced or the substituted with equal sign, we can place a proportionality constant rho. This rho is called resistivity of the material, which is constant for any material until the temperature is changed. So here I have written the explanation where the rho is constant of proportionality and it is called electrical resistivity of the material, or we can call it as specific resistance. Specific resistance. Then we can calculate the SI unit of the resistivity or the specific resistance. How can do this? We can do this like rho is equal to Ra upon L. So what is the unit of resistance? Ohm. Unit of area, meter square. Unit of length is meter. So here we will get the unit for resistivity is ohm meter. That is the SI unit of the resistivity. So it is the property of the material. Thank you.